Okay, so this worksheet looks a little bit different on my iPad than what it looks like in your hands. Some of these formulas are just a little bit messed up, but that's okay. You can just look at your worksheet as I'm going through these. So today we're talking about word problems, and really we are just using substitution to solve these word problems. So we've already learned how to do substitution. Now we're just kind of using that strategy for some real world examples. So number 1 says John and Sarah are each saving money for a car. The total amount of money John will save is given by the function 60 plus 5x. The total amount of money Sarah will save is given by the function x squared plus 46. After how many weeks, x, will they have the same amount of money saved? Explain how you arrived at your answer. So one thing that we need to take note of is that our x variable represents the number of weeks. And then our y variable, which is really just that f of x and g of x, that is equal to money saved. So what this question is asking is in how many weeks will they have the same amount of money saved? So this is saying we can assume that g of x and f of x are the same. So let's just go ahead and set these two equations equal to each other. And now we can just solve for x, just like we've been doing when we have been using substitution. So what this equation ends up looking like is x squared minus 5x minus 14 is equal to 0. From here we can just factor. This is factoring the trinomial. So we get x minus 7, x plus 2. From here, we can solve for x. We get 2 answers for x by setting both of these factors equal to 0 and solving. We get x is equal to 7 and x is equal to negative 2. Since this question is just asking us how many weeks, that's what our x variable represents. So we don't have to solve for y here. They don't really care about what the cost is. They're just wondering how many weeks it will take to save the same amount. So we get 7 weeks and we get negative 2 weeks. Well, even saying that out loud doesn't make sense. We know that we can't have a negative amount of weeks. So our final answer here is just 7 weeks. Okay, let's move on to the second one. The price C in dollars per share. Okay, so that's something to make note of, is that C is dollars per share of a high-tech stock has fluctuated over a 12-week period according to the equation that's negative x squared plus 12x plus 14, where x is in years. Okay, so x is equal to years. And the price C dollars per share of a second high-tech stock has shown a steady increase during the same period according to the relationship, or just equation, C is equal to 2x plus 30. For what values are the two stock prices the same? So this is saying for how many years will it take for our cost per shares to be the same? So we're doing the exact same process here. We're assuming that these two C values are the same. So we're going to set these two equations equal to each other. So negative x squared plus 12x plus 14 is equal to 2x plus 30. Now we set this equation equal to 0. I want to keep my x squared term positive, so I'm going to add everything, or subtract if I need to, but basically move everything from the left side over here to the right. And then your equation ends up looking like 0 is equal to x squared minus 10x plus 16. From here again, we just factor. So x minus 8 and x minus 2. We get 2 positive answers for x this time. And since it makes sense for years to be positive, so I could have 2 years or 8 years, both of these are valid answers. So let's write that out. 8 years and 2 years. Okay, this last one, we don't have that much room here, and this one definitely looks a little bit different. The revenue for a production by a theater group is y is equal to negative 50 t squared plus 300 t, where t is the ticket price in dollars, okay? T is ticket price in dollars, okay? The cost for production is y is equal to y is equal to 600 minus 50t. Determine the ticket price that will allow the production to break even. And then here, this little hint tells us that a company breaks even when revenue is equal to cost. So we just saw that revenue is given by this equation here, and cost is given by that equation right there. Okay, so if we want our revenue to equal our cost, we set these two equations equal to each other. Negative 50 t squared plus 300 t is equal to 600 minus 50 t. I want to set this equal to 0, so I'm going to add 50 t squared and subtract 300 t from both sides. And that ends up looking like 0 is equal to 50 t squared minus 350 t plus 600. Okay, so now we factor. This looks kind of ugly to factor right now, but it's really not too bad because we can take out a GCF of 50. So let's factor out a 50 from every term. And now it looks like t squared minus 7t plus 12. And now we should know how to factor this right here. That's just a regular factoring the trinomial. So now it looks like 0 is equal to 50 times t minus 3, t minus 4. And so we get two solutions for t. We get t is equal to positive 3 and t is equal to positive 4. So let's put those answers in context of our question. This question is asking us to determine the ticket price that will allow the production to break even. So there's actually two ticket prices here. They could sell the tickets for $3 or $4 and break even.